Hello everybody, this is Dr. Purdue with Rimway Educational Resources, and today's screencast is on using the TI graphing calculator to plot some points and answer some questions about functions. So you'll notice that I have the activity sheet that I'll be using for this screencast, and the before class part of the activity we would be discussing the definition for a function, which you'll notice I have listed here. A function is a rule that relates two sets of data, the inputs and the outputs, and it can be represented in a variety of ways. And in this activity, we're going to be using multiple representations, including a table, a graph, and a rule. And our scenario is about a junior class dance. And you'll notice we're given some information. The junior class club is deciding between two different ways to provide music for their dance. And one choice is to hire a band for $500. And because there's going to be a live band, they would be able to charge more for the tickets. So it would be $6 per person. Another option would be to go the cheaper route and hire a DJ for $200 and then charge $4 per person. And so what we're trying to figure out is which option is better for different number of people attending the party, the dance, in terms of the profit for the club. And if you'll notice, we are going to first use some tables of data to try to answer that question. So you'll notice here we're using function notation where x is representing the number of people attending and b of x is representing the profit for the band. So we need to do a little thinking about what that means. So for example, if 10 people attend the dance, then we know right here for the band that it's going to cost them $500. So that's a negative, right? That's going to be a cost. So it's going to be, the profit will be whatever they take in minus this $500 that they had to pay for the band. And how do we figure out what the profit is? Well, they're going to make $6 per person. So if they have 10 people attending, we can see that there's going to be $60 that they bring in, because that's 6 times 10, but they're going to have to take out the $500 for the band. So you can see that if only 10 people attend, they're in the hole $440. And we can tell that the profit here for the DJ, they're still going to be in the hole, right? But they may not be in the hole as much because the initial cost of the band is $500, whereas the initial cost of the DJ is $200. So if we do 10 people for the DJ function, it's almost the same thing except the price per ticket is $4. So instead of making $60, they're going to make $40. But instead of having to take out $500 for the band, we only have to take out $200 for the DJ. So like I said, we're still in the hole, but not quite as much. So in this case, it's going to be $160. Having trouble typing, sorry, $160. So we would continue in this manner well, I say we, actually you would continue in this manner because this is the pre-class stuff. This is what I would ask you to do before we walk in. I'm just reviewing it for the screencast in order that people who are watching this not in my class will understand what's going on. Okay, so hopefully you have filled out your table here for 10 people, maybe 50 people, 100 people, 500 people, different values in order to get a sense of when does the profit actually break even, because that's an important number to know, and also when do we start actually making money. How many people do we need to sell tickets for this dance in order to start making money? So the question that I asked for this before class activity is to write a rule to represent the relationship for the band and the DJ. So notice what we're doing here. We're taking 6 times x, because we're charging $6 per person and x is the number of people, and then subtracting 500. So that's actually what we will put here. 6 times x minus the 500. And the same thing for the DJ, except it's not $6 a ticket, it's $4 a ticket, and it doesn't cost $500 for the DJ, it only costs $200. So these are our two, what will be our two equations that we're going to graph here in just a second. And the question is, are these linear functions? Tell how you know. And hopefully you answered here that yes, they are linear functions, and how you know is that the highest exponent on the variable is 1. And that's the easiest way to tell from looking at an equation. Now, these are actually the two equations that we're going to use in the screencast. So all of this was just the prep. Those of you who are in my class who already have done all of this part, hopefully you're all on board. So here we go. I'm bringing up my TI-84 graphing calculator, and I'm going to go into the y equals button, and in y1, because that's what it tells me, right, to use y1 for the band function. So the band function is going to be 6x minus 500. So here I'm going to do 6 times x, oh sorry, let me clear this out. 6 times x minus 500. That's going to be y1, the band function. And it tells me to make y2 the DJ function. So the DJ function is 4x minus 200. So 4x, by the way, notice that I'm getting x by clicking the variable button here, which will give you x or t or delta depending on what kind of equation you're graphing. So 4x minus 200 in y2, okay? And I'm going to exit out of this and go back to the home screen. I'm going to do that by second quit. And then, because my directions here tell me I'm going to eventually graph these two things, but in order to graph them for it to look like my sheet, I need to set the window, the graphing window, and so that's what I want to show you in this screencast. So if you notice, we have a button called window right up here in these 5 buttons across the top. And this is where you'll go to manually set the window. So we need to know our x, min, and max, and the scale. So if you look at our x-axis here, hopefully you can tell by looking that we are going by 25s, right? So our scale is going to be 25. And hopefully you can also tell that we are starting at 0 on the x-axis and going to 300. So our min here is going to be 0. Our max is going to be 300. And our scale is going to be 25. Okay, now on the y-axis, notice that we're going, the scale, we're going by 200s, so the scale is 200, and we're going from negative 600 to positive 800. So our min is negative 600, our max is 800. So here in the min, to get negative 600, you want to use this key, the one that the negative in parentheses below the 3. So negative 600 to 800, and the scale, remember, was going to be 200. Okay, so now that we have our windows set correctly, and if you go back to your y equals, make sure that both of these are selected, highlighted, so they'll be both graphed at the same time, because that's what it asks us. and then just press graph. And you'll be able to see the two lines representing the DJ function and the band function. So remember, we said that Y1 was going to be the band. So if you click trace Y1 right here, if you notice right here, we're on the Y1. If we press either the up or down arrow, we can toggle back and forth between the Y1 and the Y2. And you'll notice that the very first point that your calculator gives you is a really important point. It's the point of intersection between these two graphs. So this is the point where x equals 150 and y equals 400. This is the point where the two choices of music will yield the same answer. And after this point, you see that one option gives us much more money and one option gives us much less money. So this one's going to give us less money, at least as we go, and this one's going to give us more money, in other words, faster. And so we're going to talk about the rest of this in class, but I wanted to have the screencast for you to be able to see the calculator and some of the options in terms of what we can ask, because we're going to answer this set of questions, right? What does the slope mean? What's the x-intercept? What's the y-intercept? What does it mean? And then the question is, you know, which one do you want to choose? And so this value of x equals 150, y equals 400 is really important. So notice right now, y1, I'm on the band function, right? $6 a ticket, it costs $500. And as I go along this function, if I were to put in, for example, 200 students, it tells me that my profit for the band would be $700 if we sold 200 tickets, if 200 students attended. On the other hand, if I sell 200 tickets for the DJ function, our profit would be $600. Okay, so we're going to talk about the rest of this in class, but since I know I don't have a graphing calculator in class, I wanted to show you this part. All right, so I hope you enjoyed it, and we will talk more.